is meiosis. All right, the cell will go through this 2 times. And the purpose of meiosis is to produce a cell that's going to have half the chromosomes as before, okay? So we are doing division, we're reducing, all right? Because we know that all human cells have 46 chromosomes, okay? But if I need to give, when we're talking about reproducing, and now we're talking about sexual reproduction, half comes from the mom and half comes from the dad. Well, we can't have a child with, what is that, 50, I can't do math in my head, y'all, 52. Anyways, no, 80, 92, 96, 94. Anyways, they only need to end up with 46 chromosomes. Okay, so I can't give 46, and then the father give 46. Okay, so we have to reduce that down. So that's what meiosis is. Having the cell reduce its chromosomes down to its haploid. Most of our cells floating around in our bodies are diploid cells. They have both. They have 46 chromosomes. Well, we need to have some cells in our body that are haploids. That way, when we get ready to reproduce, we're producing a child that will only have 46 chromosomes and not more. So that's where meiosis comes in, okay? The book does a lot better than I do. I'm actually just going to skim y'all's book, which sounds probably not very helpful, but we're just going to skim it to help you hit the high points. But I'm sure y'all have already read this anyway. But anyway, here we go. So, like I said, the point of mitosis is to end up with a pair of what we're going to learn is called gametes, which are your sex chromosomes, for being able to reproduce a child that has only 23 chromosomes. Okay, so homologous, that word's so hard to say, homologous chromosomes. They carry the same genes, but they only come from one parent while the other one comes from the other parent. Those are chromosome pairs. Okay, we talked about that, how your father's cells have 2 of each chromosomes, and most of your mother's cells have 2 of each chromosomes. You put those together, and that's what you're talking about with the homologous chromosomes. Okay. Now, this phase is going to be meiosis happens in 2 different phases, okay? Meiosis 1 is, the purpose of it is to duplicate and separate these homologous chromosomes, okay? Like I said, we've got to get all this separated down so our cells, or the gametes, the sex cells, have less chromosomes in it, okay? So similar to mitosis, the phases are at least called the same. Meiosis 1, I'm actually going to go to the next page. Maybe not. I'm trying to think how far ahead I want her to jump. Interphase, prophase, metaphase 1, anaphase 1, telophase 1. Sorry, I'm going blank. I was like, I don't need notes. I can just do this in my head, but now I'm struggling. Okay. It says, during interphase, the cells that will undergo meiosis duplicate their DNA, just as those entering mitosis do. But the cell entering meiosis 1 has its diploid set, but each chromosome has been duplicated. So let's go to that, which I guess we'll jump here. Sorry, y'all, I'm jumping all over. Here it's called crossing over. All right, this is where these sister chromatids are crossing over. There's a really good video link that the Amoeba Sisters explain it. It's really cool how when they cross over, they're sharing their genetic information, which the author does a pretty good job explaining that here. I'm not going to reread it. But just remember that those cross over, and there's some genetic information being transferred, which is how we can all look so different as humans, which is really good and interesting. Okay, so we have meiosis 1 and meiosis 2. Meiosis 1, we start out with those, here in prophase, you're starting out with the diploid cells. And then as you go, see here, they're lining up in the middle, we're in metaphase. And then here they're pulling apart, we're in anaphase. And then here in telophase, we have 2 different cells, okay? But if you see, they're still connected to their sister chromatids, okay? So at the end of meiosis 1, we still have, they're still connected to their sister chromatids. Now, they are haploid, which that's confusing. Like I said, you really need to watch the videos. But just know that these are considered haploids. They're just haploids that are connected to their sister chromatids, okay? So at the end of meiosis 1, we have haploid chromosomes in each of the cells. but they're connected to their sisters, and they have to be split apart again, okay? Because we're still not going to be down to 23 chromosomes. This is which we need to have at the end of meiosis, okay? So we're going to do this again. I have this underlined. I probably should read it. The big picture then is that meiosis 1 starts with a diploid cell whose chromosomes are duplicated. So we start with the diploid, and then they're duplicated, and then they finish with 2 haploid cells, in which each chromosome is still attached to that sister chromatid, but it's not an exact duplicate. And the reason these aren't exact duplicates is because all this crossing over that happened to make the genetics more diverse, okay? But, so then we go to meiosis 2, okay? We went from haploids, we're still at haploids, so here we are. We're starting here in meiosis 2 with what we ended with in meiosis 1, okay? Starting with a haploid set, but they're still connected to their sister chromatids. You're gonna have to know this, okay? So at the beginning of meiosis 2, you started with a haploid cell that's still connected to its sister chromatids, and we need to pull them suckers apart. So back to metaphase, line them up in the middle, back to anaphase, pulling them apart, and telophase, look at there. We've got chromosomes there and chromosomes there, but now they're separated, which is what the goal of meiosis 2 was, is to simply separate the chromosomes from their sisters. And that was accomplished. It just had to go through meiosis twice. Okay, clear as mud. Too bad nobody can talk back to me. Okay, and this just does a little bit better job explaining that, okay? Meiosis 1, we're still attached to the sister chromatids. We're diploid, we're crossing over, we're pulling apart. We're in telophase, where we're separated into 2, T for 2, T for telophase. And then we come down here, and we go through, because you have 2 cells, right? At the end of meiosis, you end up with 2 cells. And so down here, both of those cells will go through meiosis 2. Okay, so after both of those cells go through meiosis 2, the sister chromatids get separated, and we end up with 4. Okay, so in meiosis 1, we start with 1 cell. At the end of meiosis 2, we have 4 cells. We took the genetic information that was in this one, and we've stretched it out between 4 cells. Okay, so that would have 23, 23, 23, 23 chromosomes if we were talking about a human. Okay, that's not in this picture, but if we were talking about a human, that's what it would be. Okay. Okay, trying to think what else. Haploid versus diploid, we talked about that. There's better videos to explain it than I am. The last things we're going to talk about is gametes, zygotes, hermaphrodites, and artificial intelligence. The next parts of your book is more trying to compare mitosis and meiosis. It's really good. The video doing a side-by-side comparison of the amoeba sisters was really good. Now we're just talking about the human life cycle. So, gametes. There's 2 different cells in our bodies, okay? Somatic cells, which is everything else, and gametes, which are your sex cells. What makes a boy and a girl, okay? So, the gametes are the mature haploid cell. So, what we ended with here, we have these haploid cells, okay? These are gametes, but they're not done, all right? They got to go through some more stuff to end up being the sex cells that we need them to be. And that's what the rest of the chapter is about, okay? A gamete is when it's actually matured. There's 2 types of gamete cells. We have sperm, and there's sperm. And then on your next page, obviously, we have the egg, okay? Those are the 2 gamete cells after they get matured from the haploid cell, what they end up being. A zygote is when the male gamete cell and the female gamete cell combined and are fertilized, then you end up with a zygote, which is what we would call an itty bitty bitty baby. That's the very first name that you call the cell after it's fertilized, is it's a zygote, after those 2 have united together. And it will continue to develop, and they'll call it an embryo, and they'll call it all different names, but that's a baby. Okay, now, you don't really have to know this as much, but spermatogenesis obviously is the beginning, right? Genesis, that's familiar, of sperm. So all this chapter here talks about how sperm is made up and how it carries genetic information and how that works. And it's really interesting, and the design is really complicated. And it's just really interesting how everything has a purpose. And so anyway, there's the breakdown of that. I don't have to go through that.